Hey, good evening, everybody. Hope you're having a good, Thursday? I've lost track of the days here. Thursday, yeah. This is, what you see here are some thunderstorms that we had here a few days ago, just before July 4th. In fact, that was the morning of the 4th right there. So we had a little bit of rain in the area, helping to keep us from going into a drought. So definitely great to see that. And I've got some video from July 5th from a special contributor here. This is from, let me get the name here. I was not able to do the chroma key overlay on this, but check out what happens on the left. Slick roads, bad driving, and a car collision there. And that's what happens when you are going too fast, with a thunderstorm in the background there, wet roads, and that was an MCS that was moving into Dallas. And thanks go to Radar, R-A-Y-D-R, on Reddit, on the RoadCam subreddit. And definitely check out that RoadCam subreddit. It's just go to Reddit and put in RoadCam, and there's some very interesting clips on there. Good for helping to stay safe. Okay, we've got a few air mass thunderstorms, so-called air mass thunderstorms over East Texas, all the way back into Central Texas. Looks like we've eased back a little bit on the thunderstorm coverage, but you can see the Gulf still open south of Houston, right in this area here. Kind of a light flow coming out of there. Streamlines are looking like this, and it does look like we have some sort of boundary through the central part of Texas. Now, to find out exactly where that boundary is, we would take a look at visible imagery. So let me see if we can set this up for you. And we'll zoom in very close here on GOES 16. Well, it's got the typical tropical look there, and you can see some speed shear here. You notice that the anvil tops are moving from west-northwest to east-southeast. And then the lower level flow is going the opposite way. So two opposing velocities there means some fairly good bulk shear. So one thing that we are lacking, though, is streamwise vorticity. So we're not looking at any tornado potential or anything like that. Also, the instability is kind of on the weak side. But you can see right through here, this is in Central Texas. That is the sea breeze working inland. And I realize that we're very zoomed in there. So let me back off a little bit on that. And we'll run the animation here. And perhaps that makes a little bit more sense. There's the sea breeze working its way inland. So that would be one of the boundaries, and I don't know if you can see the other boundary. For that one, I'm going to have to zoom in a little bit. Some of our more astute viewers may have found this already. But it's not the sea breeze. See right here? Probably a couple multiple boundaries in here. That's kind of redundant. A couple of multiple. No, that would be several boundaries right there. So this is due to the couple evenings of MCSs that we've had pushing southeastward and just basically pushing one boundary after another into central Texas, and it's just kind of a graveyard of outflow boundaries. So plenty of thunderstorms in that area, and we'll take a look at the soundings and see what the environment looks like here momentarily. Okay, let me head to chat and let me know if there's any audio problems. Sometimes the mixer gets kind of messed up there. And I see we got Andrew here and Sue M. And Ryan is joining us. And Ryan, I did get your emails. I got quite a few of them, and I was not able to sort through all of those before I had to go on. I was fighting with some equipment issues here. Ron Chalfant is with us. Ryan says, blistering day here in South Florida, 102 degrees heat, no wind and no breeze. Cthulhu is here. Enjoyed a bit cooler weather in East Texas. We have TD here, noting that cooker that we had there. Lloyd McCarter, quiet and humid in North Little Rock, Arkansas. Alexi is here, and Burl H. Fred Reamer up in North Dakota there. David Moore. More thunderstorms in the Metroplex this afternoon there. And, yeah, TD asking, did that person pull out in front of that white SUV? Well, what happened on that clip was rather fast, and I'll just show that to you real quick here. And thanks again to Radar, R-A-Y-D-E-R. Let me go back to that real quick here. Yeah, what happened is there was a car, I forgot which one, it was over on the right side in that HOV lane. It decided to cross over through the barriers, and somebody threw on their brakes, and yeah, so that happened pretty quickly. But if you go to their page, their Reddit user page, R-A-Y-D-E-R, you'll be able to see that clip right there on your own there. Okay, so back to the charts, and I appreciate the use of that clip there, and Ryan Toomey's also sent me some material here, but I got really far behind the curve here, and I'm going to have to show that, I think, tomorrow here. But I will get to that. Beautiful night to barbecue and see the night sky and hear the creatures around me. Great day in Spring Hill, Florida, from Eric Hall. Storms starting fired up in Wisconsin now, warnings posted. Yeah, and we did see those cells start up in Ontario. Let me bring this up here. We'll move way up north. These storms got going about noon, just west of Thunder Bay. And basically we saw those move southeast across Duluth, across Lake Superior, and they're now in northern Wisconsin, and a couple cells out ahead of the line right there. So let's dial it back and see what things look like earlier this afternoon. I like the polar orbiter for this purpose because this is very high resolution imagery, and it goes way back to noon where you're seeing just the boundaries. And there it goes. There's the storms west of Thunder Bay, or just north of there. Let me bring up the state lines. And there it is. Very good looking CB there, just north of the border. Very bad road network for chasing, though, so that's kind of out of the question. But we'll see if we can bring up another satellite image. Yeah, that's another look at those storms there. And I think this goes back even a little earlier. Some very nice towers there. Looks like along the Trans-Canada Highway there, or... no, that looks like just south of there. But anyway, that's what's affecting Wisconsin right now, basically along the leading edge of a cold front that is pushing south. And behind that, you can see the very unstable air in the wake of that cold front. So very much a cold over warm situation. And while we're at it, let me bring up digital atmosphere here, and we'll take a look at the surface chart. We'll retrieve the latest data. It's been a while since we've seen a nice, strong cold front, so let me move that up north. Okay, so we got Ontario and Manitoba and Minnesota, and there's the plots right there. So you can definitely see that northerly flow in Minnesota, in North Dakota. And it contrasts very sharply these 70s here with these 80s. And we see, like in central Wisconsin, 86 over 69. In Madison, 84 over 68, some very humid air. And the leading edge of that cold front, roughly from just south of Duluth, maybe the UP in Michigan, right around there, all the way down to Iowa. Looks like just south of Yankton and coming into the Scottsbluff area. So that would be the layout of that cold front. And out ahead of it, you can definitely see the moisture field. Lots of 70s. And let me see if I can draw it to 72-degree isodrosotherm. There's 72 right there, 74 over eastern Iowa. And then our 70 line is roughly like that right there. So plenty of moisture out ahead of that cold front. We'll go to the SPC mesoanalysis and take another look at that with their products. And there we go. You can see the surface low right there over Lake Superior. And out ahead of that, there's our storms, and then the higher theta E air. Theta E is what ultimately dictates how juicy the air is, and you can see down in southern Wisconsin, that looks like the best air right there feeding these storms. Now I've got the La Crosse radar up, and we can take a look at a few of those cells. One of them very close to the radar, and you can see the outflow boundary right there. Shows up very nicely. Motions within the thunderstorm cloud. Let's check that out. Go to storm relative velocity. Not much motion in that storm cell at all. We see just a little bit of outbound here and a little bit of inbound. So this is just the divergence. Very outflowish looking storms there. Looks like a little bit of an outflow boundary right there also. Shows up a little bit on the spectrum width right there. And then we've got this other cell that looks a little bit stronger. This is in just north of Mauston, Friendship, Montello out in that area. Let's take a look at the velocity in that storm. And there it looks like we do have a little bit of a meso. You can see the inbounds right there and some strong outbounds right there. And let me go ahead and set a storm motion vector. We'll bring it from maybe, these are northwest flow storms, so we're going to go maybe 310 at 15. Maybe I'll drop that just a little bit. Yeah, that looks real good right there. Okay, and you can also see that the axis of this dipole is slightly tilted, slightly diagonal relative to the radar. Okay, so not only do we have rotation there, but we've also got some sort of convergence or divergence. And the way you figure that out is just figure out which side is which. We have inbounds here, outbounds closer to the radar. So that basically means convergence. So we have rotational convergence. So definitely a bit of a meso right in that spot right there. So I'm going to put a mark there. And that puts it right in this part of the storm here. So this right here, this is the inflow area of the storm. And let's check out the tops of the storm. Wow, some very good reflectivities up there. This is up at about 23,000 feet, showing about 60 dBZs. So we've definitely got some large hailstones aloft there and tops. Up about a 50, I'd probably call that 52,000 right there. So let's do a cross-section real quick. We'll do this from the inflow to the outflow area. And there is our storm. You can definitely see overhang in here. And it's got a little bit of a multicellular appearance here. You see how there's these discrete little log-shaped towers here going on. That's indicative of kind of a multi-cell line. And then the newer cells are right here, and then this is the updraft base, the newest updraft base, and this is where we would want to be if we were chasing this storm. So somewhere right in here, that's the ideal place to be. And I'm kind of curious if any chasers are out on this storm. And anyway, these are the cells out ahead of the line, and then the actual cold front is further up north. And I think some of those cells are just about out of range, but these look a little bit less organized. Definitely some very high reflectivities in those storms. And I'll go ahead and pull up the Marquette radar. We'll see what's going on way up there in the UP of Michigan. And while we're waiting on that, let me take a look at the chat. Brett Dean under a flash flood watch in South Jersey. 72. They've got a dew point of 74 there. He says like and subscribe, and I appreciate that. Sue M and Cthulhu says the audio looks good. And Ryan just checking to make sure I got the email. Mike Estwick says hello all. Ron Chalfant also seeing a few thunderstorms out his way in Southern California. And TD says thank you, just noticed. Ryan says really cool imagery, historical data. Ron Chalfant noticing a little bit of buffering, and that's probably because of all the satellite data that I was trying to pull up that probably slowed the stream down. So I'm going to, I will try to cut back a little bit on those loads. Fred Reamer, nice drying in North Dakota. Dew points were in the high 60s earlier. Cthulhu asks, does the rotational convergence implying strengthening? It can. Most of the time, yes. There's a correlation between that and strengthening. Most of your mesos are going to have both convergence and rotation. And it's especially when we have like a supercell, very high instability days, and when I start seeing like kind of like a wall of very strong convergence all of a sudden, to me that's one of the markers that I've noted precedes tornadogenesis. So sudden, rapid increase in convergence. And then usually that'll lead to a TVS signature, and sometimes the spotters will be reporting a tornado at that point. Pretty humid in Ireland at the minute, I would imagine. Some conflicting stories with a lightning strike question. Yeah, I need to check on that. Mike Estwick says, not as bad today in Denver, 91-degree high. Lloyd McCarter says, heavy precipitation warning just to shoot for North Little Rock. Okay. Yeah, we finally got the Marquette data coming in, so there we go. We've got kind of a bow echo structure right there. So all around Wisconsin and Michigan, we're seeing some outflowish type signatures there. So wind is going to be a big threat, and also probably hail. Wind gust, nickel-sized hail right there. And let's check out the velocities inside that storm. Wow. Very strong outbounds here. Now, we should check this out relative to the ground. Okay, so I've got this pulled up, and we've got about 62 knots out, but we have to keep in mind that this is 3,000 feet off the ground. So this is not necessarily what's happening down at the ground. However, these are very high velocities, so I'm sure there is some wind damage going on right now. And you can see what looks like the leading edge of the outflow right there. So I would imagine right now we've probably got some wind damage going on in the UP of Michigan, and this is going to be west of Escanaba, about 10 to 20 miles out west of there. So that's the main danger area. Let me do an animation here. So the overall trajectory of this is to the southeast. So that's probably heading there for the lake, and maybe later this evening into Michigan around Alpena, out in that area, Traverse City. So it looks like we got a windstorm on our hands right there. And we'll check back on this later and see what's going on. Okay, let's go to the charts. We've got an enhanced risk area there for Wisconsin for today. We'll go to the 250 millibar chart and look at the prevailing pattern. Let me get this centered here. And we can see long wave off the west coast and off the east coast, pretty similar to what we had yesterday. And we've got a long wave ridge in the central U.S. And it's only broken up by this medium scale wave right there over Ontario. And this is what's driving that frontal boundary right there. That's the upper level support. Jet stream running from British Columbia through central Saskatchewan. It looks like all the way down to Iowa. And then comes out the east coast around Pennsylvania right there. So you can definitely see why we have a northwesterly flow situation. 45, 50 knot flow aloft. And we'll take a closer look at that here. And keep in mind that this is this morning. We don't have the newer data yet. Yeah, the site still has 12Z. But there's the 200 millibar trough right there. We'll go down to 700 millibars, and We've got some capping in the Dakotas. You can see 11 there at Bismarck and 10 at Omaha, 14 at Rapid City. So this right here is basically where the source of the capping is at this time. Air is a lot less capped over Michigan and Wisconsin, Minnesota. And we'll take a look at one of the scutees. Why don't we do that right now? Okay, let's see here. Let me pull up International Falls. That should just be ahead of that line of storms that we saw around midday. And earlier this morning at International Falls, the soundings looked like this. So lots of northwest flow right there. And there's some elevated moisture right there from maybe about 5,000 feet off the ground to 8,000. And a lot drier close to the surface. Some very steep lapse rates, though, all the way up to about 12,000 feet. And even though we don't see much directional turning here, there is a little bit right here in the lower levels. So we basically go from northwest to southwest here. So that may be enough to give a little bit of curvature there on the hodograph, even though everything looks westerly here. Okay, let's try Minneapolis. Minneapolis also showing the very steep lapse rates. And we can see more of the tropical moisture right there from the surface up to about 8,000 feet. So average mixing ratios here about 12 grams per kilogram. And if we assume that that moisture makes it further north, we can bring that 12 grams per kilogram to International Falls. And we can modify that part of the sounding, and we can make some assumptions there based on moisture advection. So those are some different ways you can work out modification of soundings, and I think one of these days we'll have to do a sounding seminar. There's been some requests for that, so we'll try to get to that. Okay, let's take a look at Green Bay. In fact, I think, let me see if we have the current data for Green Bay. Okay, so this is going to be a current sounding for Green Bay, and relative to these storms, let's zoom out right there. Green Bay is right there. So just ahead of that line coming out of the UP of Michigan. So let's see what the environment looks like there. Well, we've got some decent moisture for that part of the country. You can see surface dew points there in the low 60s and some fairly good depth, up to about 6,000 feet. And let's check out what the temperatures and dew points are like. Okay, about 80, 81, over 70. So let's modify the sounding based on that. 80 is going to be about 26, 27 Celsius. So we're going to start right there. And you can see that there's a lot more moisture there than it looks on this sounding. We were seeing 68 to 70 there on that surface chart. So we might want to do our parcel lift from here. So this is lifting with 69 degree dew point with 80 degree Fahrenheit temperature, and we get a pretty good positive area all the way up to about 43,000 feet right there. So these layers here of steep lapse rates, those are what's helping to keep these storms going. Okay, let's see here. I'm trying to think of what we should do at this point. We'll take a quick look at the surface data, and I wanted to mention I heard from George Kochelman at the weather.us site. He mentions that globally all 50 ECMWF members are available on that site. So let me go over there and I'll show you how to get to that data. You're going to want to go to your browser and put in weather.us/model-charts/Euro. And there you'll get the full range of European data available to us, and there's the members right there. So that's new. And there's all those different runs right there. So that's more data for us to look at, and this is kind of unprecedented. I don't think we've had this range of data available online, so definitely check that out, and thanks to Jorg there. And also I want to mention Malcolm Byron. He asked me to provide a little bit of feedback, and let me bring up this link. He's going to be attending North Carolina State University in the fall, and he's looking for feedback for his weather presentations. So this is the URL to his stream. You can go back later and look at the archive if you want to get that. And this is his channel, Malcolm Byron. He's looking for, again, some feedback on his weathercast. So if you can, stop by, and if you can't find his email address, you can just email me and I'll pass it on to him. Okay, let's see. Let me take a quick look at the chat there. Send rain, please. Fire northeast of Tucson. Yeah, I wanted to look at that also. Let me go to the... We've had a fire going on in Tucson in the Catalina Mountains. That's just northeast of Tucson. And we're probably going to be buffering a little bit, but let's see here. July 6th. Okay. This is the Tucson area. And I actually used to live there near 22nd at Kolb. Long time ago. The Catalina Mountains, if I remember correctly, it's right up here near Mount Lemmon. I mean, I may be wrong, but I think that's where it is, and I believe that that's what Hiker AZ is referring to. Calgary, 30 degrees Celsius, 86 Fahrenheit there, pretty warm. EAS fan 51 checking in. Mike Estwick asking about the letter J's on the 250 millibar chart. That is the jets. I'm lost on my own charts. I've got 31 windows open. Yeah, J right here, that's going to be a speed max. So that's where the computer has analyzed the wind field, and where it detects that the value here is greater than anywhere around it, then it plots a J. So that's jet max. So one here, one there, one there, one here. Everybody gets a jet max. Greetings all from Jumping Flash. Dave Donut felt the earthquake in Calgary. Yeah, there was like a 5.8 in Montana earlier today. 700 millibar charts, question about that. This is coming from UCAR, weather.rap.ucar.edu. So they've got a pretty good weather site there too. So you can just go to weather.rap.ucar.edu, and they've got a pretty neat weather page, a bunch of products there. And maybe to break things up, maybe I can take a look at a few of these. They used to carry the profiler data on here, and that's been removed. I can't remember what the status on the profiler network is. I know there's been a lot of problems with funding, and that may be offline there. UCAR surface charts, this is always very useful. So you can click on one of these sectors and bring up a plot. And this shows us the cold front on its way south. Very easy to pick out right there. And we can even go up into Canada there and see those warm temperatures there in Edmonton. Wow, 87 here. This is up in, I can't remember what station that is. That's in that's north of Banff National Park. 91, 100 at Kamloops. I think that's Kamloops. Okay, we've got a little bit of a heat wave going on there in British Columbia. Very warm temperatures, and 86 all the way up to Fort Nelson. Good grief. Let me recenter this on Western Canada real quick. And we'll take a look up north. Okay, we are looking at Yukon. So they are up in the 70s, not too unusual. But as we go south into British Columbia, that's where we pick up the heat wave conditions, 80s, all the way up into the interior right there. And let's see, here in Washington, 101 degrees. I guess that's around Ephrata. 97, 99, 103. Yep, they are underneath that long wave ridge, and that's what I showed you earlier. You remember we were going over this chart here, and I was showing you the long wave ridge. The axis is pretty much right in this area here. They're underneath that ridge, and they're getting a lot of those warm temperatures underneath that ridge. And the warm temperatures themselves, they help build the ridge. When you have hot temperatures, you have very non-dense air, which means high thicknesses and high heights. Okay, let's see here. A little discussion about fires there in chat. Brave firemen and forest officials fighting those blazes. Yeah, definitely. Heat warning for most of Alberta, 37 Celsius, Saturday and Sunday. That's close to 100. The firefighting DC-10, awesome to watch. Fire tornadoes. Yeah, definitely. Okay, I was going to try to work in a little bit of a forecast lesson. And I'm going to start it off kind of small until I figure out where we're going with this. And let me see if I can bring up the webcam there. Okay, there I am. I don't quite have the lighting set up here very well. I got started kind of in a hurry this afternoon. Let's see. There we go. That looks a little bit better. Anyway, I was going to talk a little bit about divergence, and let me bring that up here. Divergence, that's basically the rate of removal of mass out of a volume of air at a given point. So that's the way we can define that. So one thing that we're looking for a lot is upper level divergence. So normally we find that out ahead of these troughs out in this area here. Upper level divergence, basically what's happening is over a very broad area, you're spreading mass apart in the upper levels of the atmosphere. This is up beneath the tropopause. So when you have divergence aloft, you're going to get a response in the lower levels. You're going to force air to rise to compensate for the removal of that mass. Now, when you have rising motion at the surface, you're going to have a tendency for air to converge near the surface. So that's a compensating convergent motion that happens in response to the divergence aloft. Okay. Let me see what else I want to say about that right there. Yeah, there's two forms of divergence that we see on the charts here. Let me see if I can zoom that in here. Yeah, that's better. One form of divergence we have is speed divergence. Yeah, let me see if I can find an example of that. Yeah, right here in the base of this trough. See these very strong jet stream winds, 85 knots here, compared with weaker flow out in this area here. This is kind of like a line of cars coming around the curve here, and the cars are departing this area a lot faster than they are coming in. Velocities here weaker than the velocities here, so we get divergence through a difference in speed there. Now, another form of divergence we can have is diffluence, and that's where we have the spreading of the flow apart like this. So that's what we call diffluence. Let me recenter that. I probably didn't get that just right. Okay, so there we go. That's a diffluent flow. So basically that is divergence through a difference in direction. Now, normally we let the computer models solve this. It's a little bit more reliable to do it that way. Back in the old days, forecasters actually had to diagnose that speed divergence and diffluence by hand as best as they could. But now the models are getting a little bit better at taking care of those details, so we mostly leave that up to them. Okay, let me see what else I want to show you. Yeah, there's a name for that effect that's sometimes used when you have divergence aloft. Let me just draw this out real quick. And when you have at the surface in blue, when you have convergence, we get upward motion. And that's what we sometimes refer to as the chimney effect. It can be called the chimney effect. And then the opposite, where we have convergence aloft. In fact, that's probably what's happening out in this area right here. When we have convergence aloft and divergence at the surface, we have what's called a damper effect, and that's basically where the flow is going down. And that's where we get subsidence. We get heating in the mid-levels, and that helps build the cap in those areas. So with those very warm temperatures we saw in the northern Rockies, there's probably some of that going on right now in that area. Yeah, so you see those very warm temperatures up in this area here. So it looks like we've got subsidence working on Montana right now. So that's going to be our brief meteorology lesson for today, and I'm going to try to gradually start working these in a more organized way. Eric says over 1 million acres burned in Arizona and Utah this year. His family members need rain there. Hiker says, hard to see the smoke on that satellite image, but it was spreading west most of the day, very hazy over the city. And those were the correct mountains. Okay. Okay, how does divergence play a role in the tropics? We could probably open up a whole new presentation for that. But the important thing about the tropics, just to kind of keep things simple, just bear with me, there may be a little bit of buffering while I zoom out. But the dominant player in the tropics is the intertropical convergence zone, and we see that right there. That tends to oscillate north and south depending on the season. It lags behind the sun about 2 months or so. And everything is pretty much driven there by the convergence zone here. So we see an inflow of air from the north and south, and those are the trade winds. And so that's the reason we typically see northeasterly flow when we go to Puerto Rico or Mexico. The seasonal winds there tend to be out of the northeast, and that's partly due to the Bermuda high being up in that area, the subtropical high, but it's also caused by the convergence due to the very strong heating over the equatorial areas. Okay, let's go ahead and press forward into the forecast, and after that we'll take one brief look at the radar for Wisconsin. And I did want to mention one special feature for this webcast. I decided to add this in. If you take a look at the video description, you can now donate via Streamlabs, and your donation will be thanked on the air. So if you want to kick a few bucks this way, that's another way to do it. I've been trying to figure out ways where I could let people do that and feel that they're kind of being acknowledged and get a little bit of kudos for it, and I figure that might be one way of doing that. So you are welcome to do that during the webcast, and anyway, we'll press on. My goal is to hopefully get symmetric DSL in here so I can start streaming in HD. That'll help us see the charts a lot better. We'll be able to do 720p every day. So hopefully one day we will have that. But until then, we are kind of thriving off donations here. So let's take a look at the forecast here for the Central Plains, looking at the high-resolution rapid refresh model. Overnight, looks like we have a little bit of an MCS over the West Kansas area, falls apart pretty quickly. Okay, so things are not quite as active on the Central Plains as what we had earlier in the week. Most of the action is in the Midwest. And let's take a look at what happens to that area of storms there in Wisconsin. We can see that we do have a little bit of model error. High resolution rapid refresh not detecting these storms here very well. I mean, they're definitely right down there, but so we have to kind of take that into account when we're working with the model data. But the main MCS up there in the UP in Michigan looks like the actual storms may be outrunning the models. So you look at that, the storms are all the way down to whatever bay this is. I forgot the name of the bay right there. There's a little bay north of, I don't know, is it Green Bay? Anyway, this is a bay right here. The storms have already reached that. And the high-resolution rapid refresh was not forecasting that to happen until 2:30Z. That would be like about 30 to 45 minutes from now. So that would be another way we would have to take into account model errors. So these are going to get to Michigan a little bit faster than forecast. But they will cross the lake and be in Michigan later this evening. And the tail end will be making it into northern Indiana by about dawn. And this is another area where the mesoscale models tend to have difficulty, is how far north or south the tail end is. So we could see the tail end all the way down to Indianapolis, or it may avoid Indiana altogether. So that is an area of uncertainty. And then for tomorrow, it's probably we're probably going to have the cold front catch up with everything. But if we did not have that cold front coming through, this would be an area we would look for boundaries for tomorrow. So it looks like, looks like we do get a little bit of regeneration of storms along that cold front tomorrow about 9 in the morning. So that tells you kind of a weak cap for tomorrow. See that? Just the tiniest bit of heating, and storms are already underway from Chicago all the way down to Peoria. And that'll move into Indiana tomorrow. And looks like a storm day for Indiana, Ohio, and Kentucky. Okay, so we'll head into the forecast here, because I can't think of much else to cover. For tomorrow's webcast, here's what the picture is going to be looking like. We're going to have the cold front from Lake Huron down to about Paducah, coming into the Tulsa area and into Dodge City. And you can see that there's a little bit of upslope in western Kansas, so we're going to be looking for a little bit of severe weather potential, possibly in central Kansas, assuming it's not too capped. This would be good, certainly be a good chase area right in here. We've also got kind of an easterly flow across Texas right there. So some upslope west of Del Rio, maybe on the Serrano del Burro Mountains right here, maybe the Davis Mountains also. And then for Saturday, where does our cold front go? Well, let's see here. We've got high pressure across the Midwest. And looks like our cold front has made it all the way into the Carolinas, Louisiana, and North Texas. So we're looking at the flow of the Gulf right here. Looks like maybe a little bit of enhanced precipitation potential in East Texas for Saturday. And then for Sunday, high pressure stalling and starting to merge there into the Bermuda High. Looks like the front, what's left of it, is from Georgia all the way to Texas. So possibly some boundaries there for precipitation to develop. And looks like we have a new low forming in the Dakotas right here. So maybe a new shot of cold air coming together here. This is kind of like a warm season Alberta Clipper. Yeah, see, that's heading southwest there. Okay, for Monday, looks like that low kind of comes together a little bit further. Looks like maybe a boundary right through here, through Iowa. Gulf is wide open into Texas. And whether we get precip, that's going to depend on the upper level, whether we're going to be under a ridge or not. Tuesday, lots of cyclogenesis there in the Dakotas. Looks like rain chances will be going up. Maybe a bit of a warm front right there in Iowa, in South Dakota. For Wednesday, looks like another push of cold air coming south into Wisconsin, Iowa, and Nebraska. Look at those very high dew points there, 80-degree dew points. That's some evapotranspiration there from the cornfields. It does happen from time to time during the summer. Then for Thursday, what we're seeing here mostly just a lot of lee side troughing on the high plains. We've got a little bit of a low pressure area there in Ohio with that remains of that front coming southward. And that's mostly driven by this high pressure area right here, feeding a little bit of cold air into the backside of that low there over the Great Lakes. And then we get into the weekend. Friday, cyclogenesis there in Kansas. Looks like a little bit of a front there along Interstate 70. And then for the rest of the weekend and then the following week, we'll just go through this very quickly. Looks like lots of high pressure across the Great Lakes, bringing some dry air southward. So you see we're kind of shoving those 70s south. Dry air coming southward, some nice mild nights coming up for the middle of the year, or the middle of July. And then we get the appearance of some sort of tropical storm there in the Gulf of Mexico. Looks like it's actually going for some sort of hurricane making landfall there in the Florida Panhandle. Now, keep in mind that this is 372 hours out, and this is probably not going to happen. There's a lot of uncertainty in the models at this point. We'll take a look at the NHC forecast here, and we've got Tropical Depression 4 way out there in the Atlantic. There's the forecast path, and I guess the GFS must be locking onto that and kind of bringing it into the Gulf. So all I can say is we'll see. Nobody knows for sure what's going to happen with this, but that will be in the picture in about a week. And we'll take one last look at that system in the West Atlantic, and I'll put on the streamlines there. There's our system there, Tropical Depression 4. We see it kind of dissipate into an easterly wave there, approaching Puerto Rico. Very potent easterly wave. Moving north of Dominica. Now it's starting to approach Miami on the 12th. And then you can see another easterly wave right here. So we're trying to figure out where this hurricane thing is coming from. So there's an easterly wave right there. Okay, here comes something from the coast of... this is way to the south. Okay, that looks like our little hurricane. And yeah, that reaches the Gulf. So whatever that is hits the Windward Islands there on the 15th. And we backtrack that all the way to Africa. Let me see if I can figure out... What I want to try to do is figure out which wave this corresponds to. So let me do that real quick. Going to look at the East Atlantic here and see what's going on. If this is buffering, I apologize. We're bringing in some GFS graphics here. Hopefully not much of an impact here on the stream. Okay, so that looks like Tropical Depression 4 right there, and what we may be looking at is maybe this wave right here off of Senegal. So let's take a look. Okay, that right there I think is the system. That's the 13th and then the 14th. Okay, so backtracking. Let's Let's see, I may have lost it. Anyway, I'm just kind of using, I'm kind of extrapolating this back. I think, yeah, I can't really link that back to anything coming off of Africa. So you can kind of see how far back this goes. Probably the wave that's associated with this is still over continental Africa at this time. So that kind of tells you there's a lot of uncertainty. I mean, we can't forecast a landfall at Pensacola based on something that far out. I mean, for all we know, that wave is probably way back over Nigeria right now. But, you know, we'll continue to watch that and see what happens. Okay, yeah, and Ryan says, way too much uncertainty with Tropical Depression 4 also. He thinks the timing is off and it'll break apart as it approaches the Bahamas. Conditions still unfavorable up top for a few more weeks. Okay. Anyway, I think that's about all I got for this evening. I appreciate you all watching the webcast, and let me get the closeout music going here. That'll do it for today, and have a good evening, everybody, and we will see you tomorrow.